Welcome back. Today we're going over area of a circle. So to start area of a circle, we have to go through the formula for that. And the formula for area of a circle, we can get it by breaking a circle up into pieces and using those pieces in something that we understand. So if I were to take this circle and I were to break it up and I were to line it up like this, you'll notice that we have all these little dashes here. Those are radius. And then this one over here, that distance there and this distance here would be a circumference. So I can visually see that that's going to be a radius, and then the top piece there, that's going to be half of a circumference. Now the reason why I would do that is because a parallelogram is like a rectangle, and we would just do length times width to get the area of that shape. But using that information, we can actually find the area formula for a circle. So to start out, I'm going to put those two things down. I have the length times the width, and then I go ahead and take that information. Instead of writing circumference, I'm going to write what the circumference formula was, and that circumference formula was 2 times pi times radius. So I haven't changed anything. I just, instead of writing c, I wrote what the formula was to get c. And then there's some cool things that happen here. We'll notice that I have a radius times a radius, and I have 1/2 times 2, which is just 1, or just gone. So I can actually rewrite this to be pi times radius squared. So the area formula of any circle, pi times radius squared. Now looking at the two-dimensional figure, we see those 8 pieces as they're arranged there as stated. It's a parallelogram. And based on that parallelogram, we can determine that the side length is half of the circumference. Area of a circle. So area of a circle has two pieces of information there. The first one is area that covers something. So the area of a circle, it's measuring the covering over that circle, and it's of a two-dimensional object. The next part is the formula here, area equals pi times radius squared. The radius squared there, that stands for radius times radius. So using that information, we're going to go ahead and find the area of each circle and use 3.14 for pi. So starting out, our formula, we would write down here area equals pi times radius squared. On each of these questions, I would like you to write the radius and what it equals and the diameter and what it equals. That'll be really helpful for what we're trying to do. So here's our formula. We're going to go ahead and plug in the values. So to do that, I go ahead and say area equals pi times radius, which in this case radius is 3. So that'd be radius squared, 3.14 times 3 squared. Then the nice thing about this is we can just type that in your calculator and you'll get area equals 28.6 or 26 inches squared approximately. So on number 4, what is this distance across here? Is it a radius, diameter, or circumference? Well, looking at it, it looks like a diameter to me, so that means that I'm going to go ahead and say the diameter is 10 centimeters, which makes the radius 5 centimeters. Then we use our formula, area equals pi times radius squared. We plug in those values, so area equals pi times 5 squared, and that would just be 3.14 times 5 squared in your calculator, and you would get area equals 78.5 centimeters squared. Number 5. We go ahead and find the radius and the diameter. Is this a radius, diameter, or circumference that's given? Alright, so the radius, that one right there is a radius of 6 meters, so then that means the diameter has to be 12 meters. The formula for the circle, area equals pi times radius squared. We plug in those values. We're going to use the radius, 6, so I get area equals 3.14 times 6 squared in your calculator, and we're going to get area equals 113.04 meters squared. Alright, the area of the circle, if we have that, we can find other parts of the circle, and there's actually, if you have one thing, whether it's a radius, diameter, or circumference, or area, you can find all of the rest. It's just taking it apart. So we know that we have this area formula. If we have one piece of it, we can solve for the other pieces. So number 6, we're going to go ahead and use what we know to figure this out. The very first thing is with that formula there, I notice that it says there a circle has an area of 78.5 square inches, and we want to find the radius. So I go ahead and put in what I know, which I know that the area already is 78.5, so I can replace this variable area with 78.5. I can then write 3.14 for pi, and then it would just be times radius squared. Now, solving equations, if you recall, to isolate this variable here, we're going to go ahead and get rid of this multiplication by doing division. And whatever I do to one side of the equation, I have to do to the other. Then I go ahead and divide that out, and I'm going to get 25 equals, I went a little too far, 25 equals r squared. And to get rid of squares, we have to use square roots. So I do the square root of both of those, and the square root of 25, what number times itself equals 25? Well, that would be 5. So I know that the radius is equal to 5 inches. Now moving on to the next one. I use my area formula again, and it says there the pizza has a diameter of 18 inches. It is then cut into 8 equal pieces. About how many square inches is each slice of pizza? So we don't want the area of the total shape. We want the area of one slice. So if I go through this information, I have a diameter, so I'm going to go ahead and write radius and diameter there, because my formula does not have diameter anywhere. If the diameter is 18, that means the radius has to be 9. So I go ahead and plug that value in. Area equals 3.14 times 9 squared. I multiply that through, and I get area equals 254.34 inches squared. But that is for a full pizza. To get one slice, we have to figure out the 8 slices there. We're going to go ahead and take that and find out how many square inches is in one slice. So I divide that by 8, and I get the area is approximately, and that's what we use curvy lines for, it's approximately 31.8 inches squared per slice. Okay, next question. It says a circular rug measures 8 feet across. What is the area of the rug? Well, to start out, I have to find a radius and a diameter, because this is not a radius because it's not halfway across, it's all the way across. So I know the diameter is 8 feet, which makes the radius 4 feet. I then put in my area formula and replace the radius with 4. So I have 3.14 times 4 squared, and I get a grand total of 50.24 feet squared. Okay, this one takes a little bit of understanding of what's going on. So the very first thing is, it says there's 2 fountains. They have different designs there. One's bigger than the other, and we want to find out a couple of things. The very first thing, or in the answer, is how many more square feet will the larger fountain occupy? So to start out, fountain 1, if I were to look at that, 16 feet, that means that the radius is 8 feet. And then if we look at the other one, and I guess maybe some of you are wondering why I chose radius instead of diameter, but it wants to know the square feet. That's area. So I don't want diameter, I need radius. So I go ahead and do fountain 2, and I say, okay, that one has a radius of 9 feet. So what I need to know, like I've stated, is how many more square feet will the larger fountain be or cover. So going through my work, I'm going to do the area formula for fountain 1 and for fountain 2. So in that area formula, I have 3.14 times 8 squared. So the radius was 8. I replaced radius with 8. When I multiply that through, I'm going to get area equals 200.96 feet squared. I then go to fountain number 2 and do that exact same thing. Area equals 3.14 times 9 squared. I multiply that through, and I get area equals 254.34 feet squared. Now, to get my answer, it wants to know how much larger, or how much more space the larger fountain takes up. So to find out how much more something is, we do simple subtraction. So I subtract those two areas to get 53.38 feet squared, which means in my solution, the larger fountain, it's going to cover 53.38 square feet more. All right, hopefully this was helpful for you. If you have any questions or concerns, let me know. Have a great day.